Hello there! In the previous video, we explained to you how to determine the parameters of an electric circuit that consists of only one single mesh. This time, we will be confronted with an exercise where you have to determine the currents through resistors in a circuit that consists of three meshes. And this is how the circuit looks like. It consists of 4 voltage sources and 4 resistors, and the value of each variable is listed on this area, as you can see. And the problem that we need to solve is to determine the currents as well as their directions, their actual directions, flowing through the resistors R1, R2, R3, and R4. And in addition to that, we also want to determine the electric power absorbed by each resistor. And when you see a circuit like this, and you're tasked to determine the current flowing through each resistor, the first question that comes into your mind is, how do I go about setting up an equation to determine the currents? And as we have talked in the previous video, it is always a good idea to set up your meshes and the assumed directions of current flowing through each mesh. And in the previous video, as I said, we just had one single mesh, while in this circuit we have 3 partial meshes. They are M1, M2, and M3. And what we did in the last video, and what we're gonna do this time, is to assume that the current through each mesh is clockwise. And it doesn't necessarily mean that the actual current flowing through the mesh or through each resistor corresponds with the assumed direction. And this is something that you don't have to worry about yet. Over the course of solving this problem, the math will actually reveal the actual direction of the current. How? Well, if the current value is positive, that means that it is in line, or that it corresponds to the assumed direction of current in the mesh. And if the value is negative, then the actual direction of current rounds counter the assumed direction. So, as we did in the previous video, we're just gonna look at each individual mesh and set up Kirchhoff's second law. Remember, Kirchhoff's second law stipulates that the sum of all voltages or voltage drops in the mesh is equal to 0. So let's look at mesh 1. We're gonna start with this voltage source, US1, which is 12 volts, and we start with the positive pole. That means that we're gonna treat this voltage as positive. 12 volts minus the voltage drop across R1, which can also be expressed as R1 times I1. And then we have this voltage source, and because along our mesh we encounter the positive pole first and then the negative pole, we have to subtract the voltage US3 in this whole equation. So it's gonna be minus 4 volts, and then minus R3 times I3, which is equal to 0. And I'm gonna do the same approach for the meshes M2 and M3 quickly. So let's start with US4, or actually no, let's start with R3 because it's at the top. minus R3 times I3 minus R4 times I4. And remember, the product of resistance and current is equivalent to the voltage drop. And then, let's see, we encounter the positive pole first and the negative pole, so we have to subtract the source voltage US4, and that is 8 volts. And that again is equal to 0. For mesh 3, let's start at US2. So again, this is a negative pole where our starting point is. So we're gonna start with a negative voltage value, minus 6 volts. Oh, sorry, I'm gonna make it a little cleaner. Minus R2 times I2 minus R4 times I4. And then, let's see, here we have the negative pole first, followed by the positive pole, and that is going to give us a positive voltage for US3. Plus 4 volts is equal to 0. So that's where you need to start to determine the currents flowing through each resistor. However, if you start to solve that system of equations, you won't come very far, because this system has 3 equations and 4 unknown variables. That is I1, I2, I3, and I4. And if you have a system of equations with 3 equations and 4 unknown variables, you will not arrive at a definitive solution of each variable. So, what tools do we have in the sleeve to reduce the number of currents from 4 to 3, to accommodate for the fact that we have 3 equations in our system? And one way to do so is not to use the currents flowing through each single resistor, but to use the mesh currents, M1, M2, and M3. Because, as you see, we have 3 of these currents, and we also have 3 equations, and that will allow us to find the mesh currents. And from the mesh currents, we can then also find the currents flowing through each resistor. And the relationship between the resistor currents and the mesh currents is as follows. If you look at R1, or specifically at the current flowing through R1, that current is the same as the current flowing through the whole mesh. And I'm going to label the mesh currents using Roman numerals. So it's going to be I1, and I will write it down here. Let's see. Okay, so the standard numbers indicate the currents flowing through each single resistor, while the Roman numerals indicate the currents flowing through the mesh. And okay, so I1 is equal to the mesh current, because there is no other current interfering with the current running through R1. Then we have R2, or I2, that's the current running through R2, and I2 is equivalent to the mesh current 3. Oops. Again, there is no other current interfering with that current, so we're going to label it as I in the Roman numeral 3. And what about I3, the current running through the resistor number 3? Well, if you look at the circuit, you will see that the current running through this resistor is composed of partial currents of M1 and M2. M1 runs in this direction, while M2 runs in the opposite direction. And with that circumstance, we can express the current I3 as M1 minus M2. I1 minus I2. Because if you take this mesh current as your reference, the mesh current I2 rounds counter that direction. And we have a similar circumstance for the current I4, which is equal to, now if we take M2 as the reference direction, so it runs downwards, M3 runs upwards. So you can express I4 as being equivalent to I2 minus I3. And now we can replace the individual resistor currents by the expressions involving the mesh currents. And that way, if we insert the expressions into each resistor current, we're gonna obtain 3 different current variables instead of 4, which will allow us to solve this system of equations. I will go ahead and insert the expressions and also insert the actual resistor values into the variables. I will not do that live because it's gonna take up a little time, so I'm gonna take a break here, expand the equation in the meantime, and be back with you in a few seconds. Here we go. I have inserted the ohm values into the resistance variables and also replaced the resistance currents by the mesh currents that correspond to it. And in the next step, I have also rearranged the system of equations by putting the summarized voltages on the right side of the equations. And with that, we can set up a matrix of variables in order to solve all the mesh currents. On the right side, on this area, I'm gonna put a column for I1, and then I2, I3, and the source voltage US. And for our first equation, we have minus 6 ohms times I1, and then minus 3 ohms times I1. I'm not gonna use the ohms, I'm just gonna insert the numbers directly. So in the first equation, we have minus 6 minus 3 times I1, and that's gonna give us minus 9. And then for I2, we have plus 3. For I3, we have nothing, which means 0. And for the source voltage, we have minus 6 volts. And again, I'm not gonna put the volts because if we have a matrix, we can use the numbers without the units. And then for the second equation, for I1, we have minus 3. For I2, we have plus 3 minus 12, which is minus 9. For I3, we have plus 12. And for US, plus 8. And the last row, I1 is 0. There is no variable I1 present in that equation. And then I2 is minus 12. I3 is minus 8 plus 12 is positive 4. And the voltage is 2. And if you have a graphic calculator, it allows you to solve the matrix of this system of equations right away. I'm not gonna do that in this video. I will directly write down the values that you're gonna get for I1, I2, and I3. And these values are I1 is equal to 0.949 amps. I2, and remember, these are the mesh currents, not the resistor currents yet. I2 is equal to 0.179 amps. And I3 has a value of 1.038 amps. I have rounded to 3 decimal places. And in order to find the currents running through each resistor, we're simply gonna use this set of equations and insert the respective mesh currents. And let me scroll down a little bit to make space at the bottom. I1 is equal to I Roman 1, and that's 0.949 amps. I2 is equal to Roman I3. Oops. And that's equal to 1.038 amps. The current running through resistor R3 is equal to the mesh current 1 minus mesh current 2, and that's 0.949 amps minus 0.179 amps. And that's equal to positive 0.77 amps. And finally, I4, which is I Roman 2 minus I Roman 3. Is 0.179 amps minus 1.038 0.8 amps. That's equal to minus 0.859 amps. Okay? As far as the actual direction of the current flowing through each resistor, remember, if the value of the current is positive, that means that the direction of current flowing through the respective resistor matches the assumed direction of the mesh. In our case, we have only one current that has a negative value, which is I4. And for I4, which has a magnitude of minus 0.859 amps, that means that in reference to the assumed direction of mesh 2, that's the clockwise direction here, the direction of the current flowing through R4 runs counter that clockwise direction of M2, and that means that the current flows upwards through the resistor R4. And now, in the last part, we're gonna determine the electric power absorbed by each current, which is definitely not as lengthy as this whole procedure. The equation for electric power is P is equal to the voltage times current, and that can be expressed as the resistance times the current, which gives us the resistance times the current squared. And all we have to do is to insert the resistance values into the equation and multiply them by the squares of the currents. And that way, if you have negative currents, they're gonna turn into a positive term. Let me just quickly write down the electric power absorbed by each resistor without performing extensive calculations. So you may have done the math in the meantime. If not, you can press the pause button and do it. And if you will do your math correctly, you're gonna get P1 is equal to 5.404 watt, and I have rounded the values to 3 decimal places. P2 is equal to 8.62 watt. P3 is equal to 1.779, and P4 has a value of 8.855 watt. So far so good. We hope that this video has shed some light on how to approach a problem like this, where you have to find the currents flowing through each resistor in a circuit that consists of multiple meshes. And we also hope that the information gained in this video will be useful for your homework or for your exam. Thank you very much for watching, and please stay put for another video coming up later in this course.